Alright, let's make a test bench for this project in which I made a 16:1 multiplexer and implemented a couple functions for it. So let's make a test bench for this. So what you'll do to make a test bench is you'll go to your sources list, you'll go to simulation sources, and you'll make a new simulation source, and I'll call it create file. I'll call it testbench lab5, and my cat is going to drive me crazy. Okay, so I don't know what he wants to do. We're going to do testbench lab5. Finish. Okay. Yes. And then I need to be careful that the one I want to set as top is this test bench. And I want to make sure that I am actually editing the test bench when I go to edit it, and there we go, that's good. Alright, so now I want to base it off of the one that you have in the file that you were given. That was this was the file from your class on using Vivado to program the basis board. So we have our module is called whatever, and then it has reg declare inputs in your main module as registers. So I want to have in my test bench if I look at my main module, my inputs so I would have these. And these are going to be reg. And no, that okay, messed up. That was not my main module. This is my main module. This is what I want. I was like, wait a minute, that's not right. And it was not right. So I don't do my mux. I do my main module. So I go to get these from lab5. It's like, I don't remember making 15 switches. Okay, so my input is going to be reg. And then my outputs are wires. And then I instantiate the module that I am testing, main unit under test, and so mine was called lab5. And I give it a name. Unit under test is a good one. Unit under test. Alright. So I have to call it the same thing I called my main module here, which was lab5, and then I say unit under test, and I give it the same inputs and outputs. Okay, then I do whatever kind of initialization I want to do. put that in the wrong place. Let's see. What I want is initial, begin, and then some displays. Okay, so I want initial, so this is my initialization. Then begin. And then display, this is just going to display to the screen. And so I have $display test bench start. I'm going to want to display the values of A, B, and C, A, B, C, and D. And I want to display my outputs, S and T. And I want to run through all the values of A, B, C, and D. Make those equal to 0. So I'm starting those off at 0, 0, 0, 0, and then in my main test bench, I'm going to count up from 0, 0, 0, 0 to 1, 1, 1, 1. So this line makes it a 4-bit number out of A, B, C, and D and sets it equal to 0, 0, 0, 0. Okay, then I have my main loop here is an always block, and it just says always. So always do this. So we better have some way within the loop to get out of it. Begin. You need to put a pause in there. If you don't put a pause in there, it's not going to work because I don't need to put nanoseconds in there. If you don't put a pause in there, the processor goes too fast. Then I want to display the current values that I have. And I'm going to display them in binary. And I have 4 of them there. And the values I want to display are A, B, C, D, S, and T. And so these %Bs are placeholders for variables that are binary values. And so I put %B, and what that says is after the close quotes, look for the variables that go in those places. And so it's A goes in the first spot, B in the second spot, C in the third spot, D in the fourth spot, and S and T in the last spot. Then I need, this is my way to end the loop, is to check to see if I have gotten all the way to 1, 1, 1, 1. So if A, comma B, comma C, comma D equals binary 1, 1, 1, 1, so that means I have gotten all the way to the end of my loop, then I want to display that I'm done, and otherwise I need to add 1 . Let's see, so, alright. Let's make sure I line this all up correctly. So, always begin. Pause 10 nanoseconds, display the values. If I'm at 1111, display that test bench is done, and then also finish. So then we're going to end our loop. So we're going to just finish here because we're at the end. Else not in order. We're going to add one to A, B, C, D. I don't have a begin and end on this because it's just one line. And then I can end my always loop. And I can end my module. And talking to you as if you are not watching this on video. Do you see any syntax errors? I don't. Let me save. And wonder what I messed up here. Save. Constraints are saved. Let's see if by any chance this works. So I'll run synthesis. No, I don't want to run synthesis. I lied. That's not what I want to do. Cancel. Cancel process. I want to run simulation. Run behavioral simulation. And if we look here in my display at the bottom here, it's going through the values. It's counting the values from 000 all the way up to 111, and then it's displaying the values of S and T for each of those. So for instance, for 14, it's showing S and T are both 1, and I think that was correct in how I wrote it. I had 14, yeah, they're both 1 at 14. It starts at 15, and then 14, they're both 1, and then 13, T should be 1. 13 would be right there, and T is 1, and 12, S is 1. Yeah, so it looks like it works. So that's the test bench.